All right, first example, they give us the graph of g of x. Sketch the graph of its inverse on the same grid. So what we can do is we can take our first point right here, which is at negative 4, comma 4. The x coordinate is negative 4. The y coordinate is positive 4. We switch them and make our x coordinate positive 4 and our y coordinate negative 4. That would put that point over here. While we're doing this, I'm going to draw a diagonal line dotted right through the whole thing. I'm going to label it as y equals x. Can you see that negative 4, 4, imagine flipping it straight over that line. Does it look like it would match up? Okay? So we do this with our other points. I've got, on the red graph, I've got negative 1, negative 1. What's going to happen when I switch the points now? It stays the same. And that point was right on that dotted line. Negative 1, negative 1. The next point, which is at 1, comma 3, we switch the points and we get 3, comma 1. And some of you are thinking, why can't math always be this easy? I just have to change the points. This would be great. And finally, we have on the red graph 3, comma 2. That will give me 2, comma 3. Now we have our dots and we have to join them together, but this is where sometimes we can make a mistake, is if we join them in the wrong way. How do we know how to join them? Well, it's supposed to be a perfect reflection over that dotted line. So this point will join to there. And then they're perfect reflections of each other. Now, for our brains find it, we did horizontal reflections already. Oh, that's vertical. We did vertical reflections already. We did horizontal reflections. Our brains are pretty good. Some of us still have to work at this. Pretty good to flip things this way or to flip things vertically. Flipping things diagonally sometimes causes our brain to struggle a little bit, okay? I'll tell you a way you can cheat on a quiz test, okay? You take your book, you turn it so that the diagonal line is horizontal, then you do your flip, then quickly turn it back before anybody notices. It's perfectly legal. So if you want, you can take this graph on your page, you turn your page, turn it right now, and then look at it. Does the reflection make sense to you? It might be a little easier to see than trying to do it on the diagonal. Okay? That point is the same on both. So is this one right here. Any point that's on the line y equals x means that the y coordinate equals the x coordinate. That's what that equation is telling us. If the y coordinate equals the x coordinate, then when you switch them, they'll still be the same. And this is the part where in this question it said, is this inverse a function? Yes or no? Okay? Do you remember how to tell if something is a function from grade 10 or grade, yeah, I think it's grade 10. No. That's forever ago. Okay? See if you remember this. Do you remember something called the vertical line test? The vertical line test works like this. You draw a vertical line. If moving your vertical line across a graph hits it more than once, so you see the blue graph, I hit the blue graph twice with the vertical line. Here I'm even hitting it 3 times. But the red graph, if you look at the red graph, you see that the vertical line only hits the red graph once all the way through. If it only hits it once all the way through, it's a function. If it hits it more than once, at any point, like here, boom, hit more than once, it is not a function. Because what a function is supposed to do, like we say that our calculator functions, in the English language, when we say something functions, it works. When something doesn't function, we say it doesn't work. That's sort of the English thing. In mathematics, when something works, it gives you the same answer every time. It would be really bad on my calculator if I went 2 plus 3, 5. What'd you get? Oh, I'll check it again. 2 plus 3, 7. 2 plus 3, 12. If it gave you a different answer every time, you're like, something's wrong. It's not working. So we say something's a function when you put in something and it always gives you the same answer. According to this blue graph, right now it's saying if I put in 1, sometimes I'll tell you 0, sometimes I'll tell you -2. So we say that that is not a function. So here, use the vertical line test. It is not a function. So we would say that the blue graph is the inverse, but not the inverse function. And this sometimes causes a problem on our graphs. Okay? In mathematics, it opens up a whole set of problems. For example, what's the opposite of squaring? Square rooting. What is the graph of something squared? A parabola. What is the graph? If I took these points and switched them over a dotted diagonal line, I should get this. What's the opposite of but that's not a function, right? But you have learned, what's the opposite of squaring? Square rooting. We've already learned the graph of the square root. Did you notice that your square root was half of a sideways parabola? Oh, and you know how I told you that the parabola goes over 1, up 1, over 1, up 3? The square root goes over 1, over 1, over 1, over 3, over 1, over 5. It's all connected. Okay? But we have a problem that you can't put a square root into your calculator because it can only give you one answer for it to function. So they decided, okay, for the square root, we're only going to have the top part. So we can make it a function. Now we have a function. But we have to teach students certain times that you have to add plus or minus, right? When you square root both sides, ooh. If you start with this, there's 2 answers. If you started with this, there's only 1 answer. So then we have to teach students, you have to add the plus or minus to get both of your answers. So it does cause us some problems if we want things to be functions, but sometimes we want more than one answer. Okay. Oh, of course, state the domain and range. Makes me so happy. Are you getting pretty good at domain and range? Yeah? Okay, the red one. The red one's domain and range. Does it have a smallest x value? Yes, -4. Does it have a largest x value? Yes, +3. Does it have a smallest y value? -1. Does it have a biggest y value? +4. Domain of the blue one. Well, now the smallest blue x value is -1. The largest blue x value is +4. And the smallest y value -4. Biggest y value 3. What do you notice? They switched, right? Does it make sense they switched? Well, all the way through, the key thing with the inverse has been switch x and y. If x is your domain and you switched it, does it make sense that it becomes your range? And if range are your y values and you switch them to x values, does it make sense that it becomes your domain? Okay. All right. Circle questions 4 and 9 in your homework.